There's never been a downfall quite like Boeing's in the space industry. Once the top dog in developing and launching spacecraft, Boeing now finds itself struggling with even a simple crew spacecraft. They've not only lost their leading position to SpaceX, but have also hit rock bottom. 2024 is shaping up to be the year Boeing's problems are fully exposed, from management issues to engineering failures. Today, we're diving deep into the ongoing tragedy of their Starliner project and how things are getting worse by the day. But before we get into the details, make sure to subscribe to our channel for all the latest updates in the space world. Originally scheduled to launch in 2017, the timeline for the Starliner launch was repeatedly pushed back due to a mix of funding issues and the challenges of developing a new spacecraft. The first major setback occurred in December 2019 when an uncrewed test flight failed to reach the International Space Station due to significant software glitches. This failure required a comprehensive investigation and redesigns, which further delayed the project. On June 5, 2024, after years of setbacks, Boeing's Starliner launched aboard a United Launch Alliance Atlas V rocket from Cape Canaveral, Florida. This mission, known as the Crew Flight Test, aimed to certify Starliner for human spaceflight by demonstrating its capabilities with a crew on board. Astronauts Butch Wilmore and Suni Williams were part of this critical mission. Despite the rocky path to launch, Starliner managed to reach orbit and perform the necessary maneuvers to dock with the International Space Station on June 6, 2024. This docking was a significant milestone for Boeing, marking the spacecraft's first crewed docking with the International Space Station. The mission was initially supposed to keep Starliner docked for just over a week. However, soon after docking, engineers discovered several issues, including helium leaks in the propulsion system and problems with the reaction control thrusters. These issues required extended diagnostics and tests to ensure the spacecraft's safety for re-entry. By mid-June, NASA and Boeing announced the first of several delays to the spacecraft's return. Each postponement was due to the need for additional testing and data analysis to understand and resolve the problems. As a result, the mission duration was extended from the planned 8 days to nearly a month, with the return date being pushed back multiple times. Throughout the extended stay at the International Space Station, astronauts Wilmore and Williams, along with ground teams, conducted extensive tests on Starliner's systems. The primary issue was a series of helium leaks that engineers had to understand and fix. Tests showed that while the leaks had decreased, they persisted, requiring further investigation. The thruster issues were also a major concern. One of the reaction control system thrusters was not functioning correctly during the docking phase. Additional tests were carried out to replicate the conditions and understand the malfunction. Boeing's Starliner mission has been facing some technical issues from the very beginning, even before the spacecraft reached the International Space Station. The first crewed launch, initially scheduled for May 6th, was delayed due to a problem with an oxygen relief valve on the Atlas V rocket's Centaur upper stage. This valve malfunction forced the mission teams to halt the launch just hours before liftoff. This was not the first delay. Earlier, in March 2024, the mission was pushed from April to July to give teams more time to complete certification work. The delays continued to pile up as new issues were discovered. For instance, parachute components known as soft links were found to have a lower load limit than expected, significantly reducing the safety margin of the parachute system. Additionally, flammable tape used to wrap wire harnesses was identified as a fire hazard. On June 2nd, another launch attempt was scrubbed less than 4 minutes before engine ignition due to last-minute computer issues. The ground launch sequencer, which manages critical launch operations, detected a problem that prevented the countdown from proceeding. This led to astronauts Butch Wilmore and Suni Williams disembarking from the fully fueled rocket and returning to crew quarters. Despite finally launching on June 5, 2024, and docking with the International Space Station on June 6th, the mission faced more setbacks as we discussed in the early parts of video. Now, NASA made a statement indicating that Starliner's return would be delayed until at least early July. The lack of a specific return date tells us even more about the uncertainty and ongoing challenges faced by Boeing. The astronauts provided positive feedback on the spacecraft's systems and comfort, but some reports tell a more disturbing story about the astronauts' health. The delay in returning from space poses significant health risks for astronauts. These include bone loss and muscle atrophy due to the lack of gravity, which can weaken bones and muscles. Fluid redistribution in the body can lead to cardiovascular issues and increase the risk of kidney stones. Astronauts also face sensory and balance problems, space motion sickness, and higher exposure to radiation, which raises the risk of DNA damage and cancer. As of early July 2024, Starliner remains docked at the International Space Station, with no confirmed return date. The ongoing tests and evaluations are critical to ensuring the spacecraft's readiness for re-entry and future missions. NASA and Boeing have emphasized that the extended duration is not a constraint, as the International Space Station has ample supplies, and there are no immediate scheduling conflicts with other missions. Now, something even more serious is happening. The lives of astronauts are at risk. Boeing had one chance to turn public anger into appreciation with the Starliner project, but it seems they've blown that chance too. Now, it's not just about their reputation. It's about the safety of the astronauts stuck at the International Space Station. As Boeing and NASA continue to address the Starliner issues, there appears to be one very reliable option for the astronauts' return to Earth, and that's SpaceX. The launch of Boeing's Starliner has been a journey filled with multiple challenges, even before it successfully docked with the International Space Station. Initially scheduled for earlier dates, the first crewed launch attempt on May 6 was scrubbed due to a valve issue in the Atlas V rocket, which regulates the pressure on the upper stage. This valve was found to be malfunctioning, leading to a last-minute cancellation. Following this, the launch was rescheduled but faced another delay on June 1st, when a computer card issue in the ground launch sequencer caused an automatic hold just minutes before liftoff. Engineers identified a problem with the power supply unit in one of the ground control computers, necessitating the replacement of the faulty component before another attempt could be made. Despite these problems, the Starliner successfully launched on June 5th from Cape Canaveral Space Force Station. Aboard the spacecraft were veteran NASA astronauts Butch Wilmore and Suni Williams, who were tasked with testing the vehicle's systems in preparation for future operational missions. The spacecraft reached a safe and stable orbit, docking with the International Space Station on June 6th. Now, you might think the issue has ended when the spacecraft docked with the space station. But the challenges continued to mount with technical issues and delays that have extended the return mission. Initially, the Starliner was scheduled to return on June 18, 2024, but this was delayed due to the need for additional preparations and spacewalks that were originally planned for June 13th. These spacewalks were subsequently canceled due to spacesuit discomfort. The return was then rescheduled to June 22, 2024. However, this date also faced postponements due to ongoing technical issues with the spacecraft. Specifically, the Starliner experienced helium leaks in its propulsion system, which required further investigation. Again, on June 18th, NASA announced another delay, pushing the return date to June 26, 2024. However, experts believe that the mission will be delayed even further, as Boeing still does not seem to have fully understood the underlying problems. This leaves us with only one reliable option: SpaceX. SpaceX has consistently proven its reliability launching its Falcon 9 rocket almost every week. The company's track record includes numerous successful crewed missions to the International Space Station using the Crew Dragon spacecraft. Since the introduction of the Falcon 9, SpaceX has completed over 200 successful missions, and unlike Boeing, which has struggled with continuous technical problems, SpaceX has maintained a strong safety record. SpaceX's Falcon 9 is so reliable that when companies face significant issues, like Boeing is with the Starliner, they often seek help from SpaceX to ensure the safe return of astronauts. For example, in December 2022, the Russian Soyuz spacecraft suffered a significant coolant leak while docked at the International Space Station. This incident raised serious concerns about the spacecraft's viability for safely returning its crew, which included Russian cosmonauts. In this emergency, NASA considered using SpaceX's Crew Dragon as an alternative return vehicle. The Crew Dragon spacecraft launched atop the Falcon 9 rocket and successfully docked with the International Space Station, where the stranded astronauts were quickly transferred aboard. Following meticulous safety protocols, Falcon 9 safely returned the crew to Earth. However, when it comes to the Starliner, Boeing does not want to be rescued by SpaceX. They view this as a significant humiliation, having a newcomer like SpaceX rescue the oldest commercial space company from disaster. Boeing has a long history in aerospace, making it one of the most established names in the industry. It started with a capital of just $100,000, but quickly grew into a giant, playing a significant role in space exploration. By the time SpaceX was founded in 2002, Boeing was already a giant with a market capitalization of over $70 billion, boasting extensive experience and resources in aerospace engineering. SpaceX started with much smaller capital, but rapidly gained traction due to its innovative approaches and successful missions. Both Boeing's Starliner and SpaceX's Dragon were developed under NASA's Commercial Crew Program, aimed at creating a cost-effective transportation to and from the International Space Station. NASA awarded contracts to both companies. Boeing received $4.2 billion, while SpaceX received $2.6 billion. Despite receiving a larger sum, Boeing's Starliner has faced numerous delays and technical issues. Initially expected to be operational by 2017, the Starliner program encountered a series of setbacks that significantly pushed its timeline. Meanwhile, SpaceX, with a smaller budget, managed to complete the development of the Crew Dragon more efficiently. SpaceX's Crew Dragon had its first successful uncrewed test flight in March 2019, followed by its first crewed mission in May 2020. Since then, the Crew Dragon has been used for multiple missions, earning the title of the safest spacecraft in the world. The fact that both Crew Dragon and Starliner were developed under the same NASA program makes Boeing's situation even worse. Despite having a larger budget and more resources, Boeing's delays and technical issues have resulted in SpaceX emerging as the more reliable and capable partner for NASA. You might be wondering, how can giants like Boeing handle a spaceflight situation so poorly? Firstly, Boeing's internal issues have significantly impacted the Starliner project. The company has been dealing with a series of quality control problems, including those seen in their commercial aircrafts. Unlike SpaceX, which primarily focuses on rocket launches and space exploration, Boeing's vast business portfolio spans commercial aviation, defense, and space. This diversification means that Boeing's leadership and resources are often spread thin across different sectors. The company has faced multiple crises, including the grounding of the 737 MAX and production issues with the 787 Dreamliner. Many experts believe that NASA should reconsider its investment in Boeing's Starliner and halt any further funding for the program. Boeing has already incurred significant losses, with estimates of around $1.5 billion beyond the NASA contract. It's understandable that NASA aims to prevent a monopoly by not solely funding one company. However, there are other reliable companies aside from SpaceX that could fulfill NASA's requirements. For example, Dream Chaser project is nearing its first orbital flight test. This spacecraft is very different from others like Starliner and Dragon, offering unique capabilities and design. Dream Chaser is often referred to as the mini shuttle because it is designed to be reusable and can land on conventional runways. The Dream Chaser can carry both crew and cargo, and its horizontal landing capability sets it apart from the vertical landing approach used by both the Starliner and Dragon capsules. When we hear how other companies struggle to meet their expectations, it's hard not to appreciate the one company that completed their project on time: SpaceX. NASA originally picked SpaceX, Boeing, and Sierra Nevada Corporation's Dream Chaser for its Commercial Crew Program. SpaceX received $2.6 billion, and Boeing received $4.2 billion. SpaceX, under the leadership of Musk, developed the Crew Dragon spacecraft. Since its first crewed flight in May 2020, Crew Dragon has successfully transported astronauts to the ISS multiple times. Its ability to launch on time and meet NASA's rigorous standards has set a high benchmark in the industry. Despite receiving the largest portion of NASA's investment, nearly double that of SpaceX, Boeing has struggled to deliver. While Boeing struggles to achieve a reliable spacecraft with the Starliner, SpaceX is making history not only with Crew Dragon, but also with Starship, the largest rocket ever built. They have become so big that even huge organizations like NASA are seeking their help. This is a big win for SpaceX, both in terms of money and trust. Recently, NASA entrusted SpaceX with a major task worth hundreds of millions that no other private company has ever been trusted to do before. What's funny about this is the timing. Just when Boeing is struggling to return astronauts from the International Space Station, SpaceX achieves another major milestone. This is more than just an embarrassment for Boeing. It highlights SpaceX's growing dominance and reliability. The International Space Station orbits the Earth approximately every 90 minutes, traveling at a speed of about 17,500 miles per hour. The space station consists of modules and components from various international partners, including NASA, Russia, Japan, Europe, and Canada. As the station approaches the end of its operational life, a safe and controlled deorbit process is necessary. Deorbiting is the process of bringing a spacecraft out of orbit, leading to its re-entry into Earth's atmosphere. This ensures that the station does not become space debris, which could pose a significant hazard to other spacecraft and satellites. Historically, the deorbiting of large space structures has been managed carefully to avoid uncontrolled re-entries that could scatter debris over populated areas. Controlled deorbiting involves precise calculations and maneuvers to direct the spacecraft into a remote part of the ocean, often referred to as a spacecraft cemetery. In the past, space agencies have used various methods to deorbit satellites and smaller space stations. For instance, Russia successfully deorbited its Mir space station in 2001 by using a series of controlled burns to lower its orbit and direct it into the Pacific Ocean. Now, NASA has assigned SpaceX the critical mission of deorbiting the International Space Station. They awarded SpaceX an $843 million contract to build the United States deorbit vehicle. This specialized spacecraft will be responsible for safely deorbiting the International Space Station at the end of its operational life, ensuring a controlled re-entry into Earth's atmosphere. The deorbit vehicle will likely draw upon SpaceX's experience with their Dragon spacecraft, which has been successfully transporting cargo and crew to and from the International Space Station for years. The initial estimate for the contract was over $1 billion, but thanks to SpaceX's cost-effective reusable vehicles, the final amount was reduced to $843 million. Meanwhile, NASA astronauts are currently stranded on the International Space Station due to ongoing issues with Boeing's Starliner spacecraft. Originally scheduled to return to Earth on June 13th, astronauts Butch Wilmore and Suni Williams have seen their stay extended multiple times because of numerous technical faults with the Starliner. The problems began during the spacecraft's 25-hour flight to the International Space Station, where engineers detected 5 helium leaks and failures in 5 of the spacecraft's 28 thrusters. These issues have forced NASA and Boeing to delay the astronauts' return to at least June 26th, as they work to troubleshoot and fix the spacecraft's malfunctions. The Starliner's journey has been filled with delays and repeated technical failures. This has naturally cast a shadow over Boeing's reliability in space missions. Meanwhile, Musk is not only focusing on revolutionizing the rockets but also the engines, and he has recently came up with mind-blowing upgrades to the Raptor engines. Musk first got the idea for the Raptor engine back in 2009. Initially, they thought about using hydrogen and oxygen, but by 2012, they shifted to methane and oxygen. Methane is a better choice for missions to Mars because it can be produced there using the Sabatier reaction, which combines carbon dioxide from the Martian atmosphere with hydrogen. The first version, Raptor V1, started testing around 2014. This version had a thrust of about 225,000 pounds and used a lot of 3D printed parts to speed up development. It was a complicated engine, with lots of plumbing and sensors to help SpaceX learn how to control it. By 2022, SpaceX rolled out Raptor V2, and it marked a significant leap forward in rocket engine technology. This version was not only more powerful, but also simpler and lighter. The engineers at SpaceX streamlined the design by removing a lot of the extra plumbing and sensors that were necessary in the early versions. This reduction made the engine more flame-proof and heat-resistant, crucial for the extreme conditions it faces during launches. Raptor V2 increased its thrust to an impressive 230 tons, making it the most advanced and powerful engine SpaceX has in operation. This engine set a new record with a chamber pressure of 300 bar, surpassing previous records held by engines like the Russian RD-180, which operates at 267 bar. The Raptor V2's chamber pressure is not only the highest for any rocket engine ever built, but also contributes significantly to its performance and efficiency. To put this into perspective, the Space Shuttle main engine had a maximum chamber pressure of around 207 bar, which was considered groundbreaking during its time. The F-1 engines used on the Saturn V rocket, which took humans to the moon, had a chamber pressure of about 70 bar. These engines were powerful in their own right, but the advancements in materials, engineering, and design have allowed Raptor V2 to achieve higher pressures and efficiency. Although Raptor 2 sounds almost perfect, SpaceX isn't stopping there. They are already advancing to the next level with Raptor 3. Musk recently shared some exciting updates about this next-generation engine, which promises to bring even more improvements and efficiencies. Musk responded to a tweet about the impressive number of Raptor engines currently being produced, stating, "We could build a lot more. But the next version of Raptor is really the one to scale up production. We begin testing it in McGregor within a week or so." One of the standout features of the Raptor 3 is its regenerative cooling system, which integrates secondary flow paths throughout the entire engine. This innovation eliminates the need for an external heat shield, a significant change from previous versions. Without the need for a heat shield, the engine's design becomes much simpler and lighter, reducing overall weight and complexity. This change also removes the necessity for over 10 tons of fire suppression systems that were previously required behind the engine heat shield. Testing of the new Raptor 3 engine is set to begin soon, promising consistent firings at SpaceX's McGregor test site. It's worth noting that around this time last year, SpaceX was conducting some of the first Raptor V3 firings. And that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.